Today, I'm very excited to be here with Mr. Kevin Dykema, who is the president of the National Council of Teachers of Mathematics and a math teacher at Matawan Middle School in Michigan. And I am super honored to have you on, and we're here today to talk about detracking in math education. So I guess we'll just start off with what is tracking?
Yeah, so tracking is really sorting students, and it often starts in the elementary grades, and it's more prevalent in the middle school and the high school grades, where we deem some students are very capable of doing math, so we put them in a higher track. We deem that some students aren't capable of doing math, and we put them in a lower track. And oftentimes, those different tracks lead to drastically different outcomes and drastically different opportunities for different students. And we always need to be looking at what are some ways that we can increase opportunities for every single student, not just for some select students.
Yeah, so what are some of the larger ramifications of tracking, would you say?
Yeah, so I think, historically, when we've looked at tracking, those that are in some of the so-called lower tracks end up sort of in dead-end courses where they take the same material and are constantly repeating it. They don't have those same opportunities as those that are in those higher tracks. And when we look at historically, when we look at data, it is very racially segregated who's in those higher tracks, who's in the lower tracks, and we're preventing opportunities for many students to be able to do that, and it's limiting those opportunities. I also wonder about how many students are misplaced in those tracks, that whatever measures are being used in districts that are tracking, oftentimes I wonder, is that measure really an accurate reflection of what they are capable of doing? And how many students who are in a lower track really are just as capable, if not more capable, than some that are in a higher track? And I often, as I work with districts, I hear places who have track this, they're frustrated that in the middle school already, there are parents saying, "Oh, I'll just get my kid a tutor to stay in that advanced track." Well, what message are we sending the kids at that point in time? Are we instilling a love of mathematics? Are we helping them see that mathematics is something that they can understand? Or has it become just that subject that, oh, we'll just have to keep tutoring you to keep you going along? And how many kids then end up in the higher track and end up absolutely hating math and not wanting to do any math later on in life?
Would you say that there's also sort of like mental barrier that is imposed by tracking for those they're sorted into the lower tracks?
Oftentimes, yeah, they see themselves as not capable of doing the mathematics, and when they're being told, "Oh, you're not very good at math," why would they want to continue to work hard at math? And when they start to see their course names look drastically different than the course names of some of their peers that are taking, and it ends up they're limiting their opportunities later on. And as an education system, we need to be doing whatever we can to increase opportunities for everybody. And we all know that everybody develops at different points in time. And when we have such rigid tracks, oftentimes they're already sort of starting in sixth grade, and it's tough to know for sure where their mathematical capabilities are. And sometimes it's the way that we're teaching the mathematics. That if we look at teaching the mathematics in different ways, would we better meet the needs of more of our students?
Yeah, and would you also say there's like a differential in the quality of instruction between tracks and the quality of the teachers?
Oftentimes there is, and there's a lot of time that the higher tracks are given the most veteran teachers, the most experienced teachers. Not that experience equals quality, but oftentimes that is, it's sort of, especially in the high school, it's sort of a badge of honor to be able to teach those AP classes and those upper advanced classes, and you sort of have to work hard to get to that point. And we give our most inexperienced teachers oftentimes the students who most need a good high quality math instructor to start off their high school career. So there's definitely the tracking of students, but tracking of teachers is also an issue.
Yeah, so would you say that the tracking problem could be solved just by investing more in better teachers for lower tracks, or is there a lot more that we can do than that?
Yeah, I think it's a lot more than just investing in the higher quality teachers, more experienced teachers, and supporting those in the lower tracks. I think we need to look at the systems that we have and what can we do differently, and is tracking really the best thing, and who is that really serving? And and as I talk with other teachers, they'll ask their AP calculus class, for example, that's tracked, why are you taking this AP calculus class? And the number one answer is so I never had to take another math class in my life. Well, I'm not sure that should be the purpose of having an advanced math class, an advanced track in there. If we're looking at getting kids passionate about mathematics, and if we're saying, oh, we need to have a well-educated going into the university system for STEM careers, are we really doing that by tracking, or are we just pushing some of our students so rapidly through some of the mathematics they begin to hate the mathematics? And oftentimes students in the higher tracks, they reach a point. I mean, we all reach a point where math doesn't come incredibly easy, that we have to work hard at it. But when we're in an advanced math class and in that higher track, and you reach that point, all of a sudden you start doubting yourself and you think, I don't belong here and I'm not capable of doing the mathematics. And we need to do whatever we can to help increase the opportunities for everybody and help everybody recognize you are capable of learning math, and that math can be a difficult thing to learn at times, but it's such a valuable subject.
Mm. So why is detracking so important? Why is like diversity and heterogeneity so important in the math classroom?
Yeah. So I think, it's an important thing because we can all learn from each other. And I think that so often when we look at those who have been placed in a higher track, I wonder, do they really understand the material? Or had they just memorized what to do? And there's a big difference there between understanding and memorizing. I was talking with some university folks last week on a call from some very prestigious universities, and they were saying, they're finding that more and more students who are taking AP calculus in high school are getting to the universities, and they really don't have an understanding of what calculus means. They're able to do the differentiation, they're able to do the integration, but they don't know why any of that's working. That their complaint is that the high school system, the K-12 system, is really turning out a lot of rule memorizers. They're able to do the calculations, get sort of the right answer, but they have no understanding what's going on, no problem solving skills. And I wonder, when we put students in a heterogeneous thing, does that also allow us that time to have our students doing more discourse with each other rather than just sitting and listening to the teacher talk, giving those opportunities to really develop a good, solid understanding of the material so they know what's going on.
So that's interesting. But would you say that calculus is a high school class or should that be more of a college class?
Yeah, and that's a very, very good question. That's one that people are continuing to wrestle with. And I would say, 20 years ago, calculus was not considered a high school class. That it's really within the last 15, 20 years, as we focus so much on accelerating students in the hopes that we're meeting their needs. And I don't see a need that as many students who are taking calculus now really do take calculus. I'm not sure why calculus has become sort of this badge of honor for high schools, that we feel this burning passion to get our students through calculus. There are many people who are very, very successful in life who did not take calculus in high school, took calculus in college at the university level, and came with that nice, solid foundation and truly understood what's going on, and then they're ready. Now, does that mean that there are not some students who are very, very capable and should be learning calculus in high school? There are probably some students who are very capable and should be potentially learning it in high school. But I think that we've turned it into a course that there's the perception that if you're not taking calculus, you're not doing something right in high school. And I strictly think that's just not the case. And I would argue there are other classes that are just as important for many students. I think about AP statistics or a data science course. For many careers, that's a much more valuable course than an AP calculus class. And yet we've sort of put AP calculus on this pedestal and say, oh, we have to get all of our students, we have to get our so-called top students, the ones that we perceive as very, very gifted in math, we have to get them through calculus in there. And we're turning out students who just don't like math. and are rushing to get through calculus so they can get in high school and never take another math class. And if these are our so-called strongest students, these are the ones that we should be encouraging to take STEM careers and should be looking at majoring in mathematical related universities, and they're just not.
Yeah. And in Princeton, it's a pretty well-to-do town, and there's a huge proportion of students who take calculus in high school, and it's almost half almost, and they're even our school offers classes even above calculus. And when Dr. Mailau came to our district, when we hired him, he suggested a curriculum that seemingly like eliminated calculus, which a lot of parents like blew up about. Does detracking entail eliminating those higher tracks above calculus or at calculus?
Yeah, and I think different districts are doing it different ways. And one of the things that, as we look at, and it's a growing trend throughout the nation of looking at how do we detrack classes, but many of them are also still recognizing there is a proper role for acceleration of some students, not as many students as what are currently being done. And so there are some schools that are offering some summer acceleration programs so that students still can get an AP calculus class in college or something beyond that as necessary. But again, I keep coming back to this. We want to make sure we're increasing opportunities for every single student. We want to make sure that our students who are in those so-called top tracks are leaving with an appreciation of mathematics. And it's not just that I want to get as many of those college classes done in high school so that I never have to take another math class in the rest of my life. That's not a helpful thing. We want our students who we deem to be, and it may be accurate deeming, it may be inaccurate deeming, but those students that we're deeming to be our strongest mathematical students, those that we've historically placed in those higher tracks, those are the students that should be taking lots and lots of math in the college level and the university level, majoring in the engineering and the science, the technology, the mathematics careers, and they're just not. That they're leaving high school not enjoying mathematics anymore. And we've got to take a strong look at why is that? And many people are saying detracking is a way to really do that. But I think it's more than just the detracking. I think it's the how we teach mathematics. That so often, when we think about teaching mathematics, it's been the teacher tells you exactly what to do. You memorize the steps, and then you just sort of regurgitate what the teacher has done with a different set of numbers. And that's not leading to an appreciation of mathematics. That's not developing competent mathematic students for every single one. Is it working for some students? Potentially. But if we're looking at broadening and continuing to make a math literate workforce, we've got to really examine both those structures and the how we're teaching mathematics.
So what would you say is the better alternative rather than the formulaic method of teaching mathematics?
Yeah, I think we give our students the opportunity to start to make some sense. I am not saying there's never a place for some of that more formulaic thing, but I think in historically in many places, when I was a student, I mean, it was very much the teacher said step one, step two, step three. We memorized it. And I don't think I really understood. I know I didn't understand what was going on at that point in time. And I saw math as all these different isolated topics. And it wasn't until I started teaching that I started to see the connections between things. So I advocate for it. Let's let our students start to make some sense of the mathematics. Instead of me telling you exactly what to do, let's put a well-designed exploration together so that the students can start to make some sense. Do I think that that's going to be enough? Do I think that just giving the students an exploration and saying, hey, start to make some sense, that they're going to have that full understanding? Absolutely not. But when they start to have some sense of what's going on, then we can provide those a little bit more step by step, and think of it more of as a summary of what have you started to learn from there. One example I'd have to think about the high school level, when we think about the quadratic relationships, and we have that vertex form, and we have that y equals a times the x minus h squared plus k. I just memorized that hk was the vertex, and that h moved it left, right, k moved it up, down. Why aren't we using graphing calculators? Why aren't we using Desmos? Having students investigate that, having them recognize, when I switch the number inside that parentheses, that's moving that vertex left, right. Let's get our students that opportunity to start to make some sense. And then we can provide some of those consolidating the thinking type of notes. And I think we just need to continue to work on, let's get our students to understand what's going on, help them start to make those connections so they don't see mathematics as all these isolated different topics, but that they see it's a beautiful thing, and that there's so many connections between so many different areas in the math.
Yeah, and I've heard a lot about the integrated curriculum, which is rather than having classes separated by algebra 1, algebra 2, geometry, pre-calculus, we have more of a united just whole math class.
Yep. Yeah, and and it's always interesting to me. The United States is one of the only, if not the only, nations that does the algebra, geometry, algebra two, or some variation of that. The rest of the world has integrated math, and they're helping the students see all those connections with that. And I wonder why in the United States we're so ingrained with that. And I think it was back there was a committee of 10 back in 1892 that said, hey, let's do the algebra, geometry, algebra 2. And we haven't changed that structure in the high school in well over 100 years. And the needs of a workforce of a society back in 1892 is definitely different than the needs in 2022. So I think it's well past time to have those good conversations and to look at what are some structures that we can do in the high school to better meet the needs of our students and to continually increase opportunities for students.
Yeah, and I was just curious, what would you say is the difference between acceleration and detracking and acceleration and tracking?
Yeah. So the difference, when I think about tracking, I think, hey, we have our low group, our medium group, our high group, and we call them different things. Some places have 2 tracks, some places have 3 tracks, some places have 4 tracks, and they lead to drastically different things. That those in the low track will never have those opportunities to get some of the higher math classes, and we start calling them. We have a tier 2 geometry class. It looks nothing like a regular geometry class. Or we have an intensive support algebra 2 class. It looks absolutely nothing like a regular algebra 2 class. So that's what I think of when I think of tracking. When I think of accelerating, we have a common pathway. There is an algebra course, there's a geometry course, there's an algebra 2 course, or we call it math 1, math 2, math 3 if we're going integrated. And some students are, if we think of algebra 1 as a ninth grade course, there may be some ninth graders who are then instead taking geometry, but the geometry that a 10th grader is taking is going to look the same as the geometry that a ninth grader would be taking. And right now, so often, when we look at tracking, those in the higher track, their version of algebra 2, for example, looks very different than the version of algebra 2 for somebody in the on grade level track or a below grade level track. And that's just plain out wrong, that the same course can look drastically different for different students. So we need to have that common set of expectations, and then just maybe some students that can progress through that a little bit quicker and may end up in a little bit different spot. But we've got to increase those opportunities and ensure that our courses are looking the same no matter which student is taking.
And why do you think it's so hard to implement detracking in so many school districts right now? Why is there so much resistance against it?
Yeah, change is hard. And because it just looks different than what the thing. And no parent wants their no parent wants to limit opportunities for their students. And I think so often many communities view detracking as limiting opportunities for some. And there are many districts that are showing that detracking is not limiting those opportunities for some. And I think in this day and age, any change in education is incredibly difficult, that there's so many different voices with so many different perspectives that getting everybody to agree on any change in education is very, very difficult.
I think when a lot of critics look at detracking, they kind of characterize it as you're cutting off like opportunities for the best students because you're kind of cutting off the higher tracks. Why would you say that that is not cutting off opportunity? What would you say to those people?
Yeah, and I would say, there are ways that we can still give those students some of those opportunities. And I keep coming back to the why do we have this need to push our students so rapidly through there, and what is the outcome of those students who are in our top track? Are they all going on into STEM related careers? No. So what's the purpose of putting them in a class where they end up dreading and end up turning them into students who hate mathematics and don't want to take any more math and have a distaste for that? I would much rather a student leave high school feeling capable and competent and wanting to learn more mathematics.
And do you think part of the resistance is like families trying to have their students taking harder classes to like impress colleges to increase their chances of like admissions to colleges and that sort of thing?
I definitely think that is part of it, and there is a perception out there, and I don't think it's an accurate perception that all universities want students to have calculus so that you get a better chance of admission into a top university, so to speak, if you've had an AP calculus on your transcript or courses beyond that. And there's definitely continued work that needs to happen between high schools and university admissions counselors to help them educate both sides. What are those expectations? Is that truly just because it's the perception among so many communities and so many families? Is that truly the reality among the universities? And I'm hearing from more and more universities that it's not the expectation. They don't expect students to have to need AP calculus there, and that it doesn't do them any good to have the AP calculus. It doesn't increase their chances of getting into the universities. So there's increased dialogue that needs to happen with our university systems to help educate everybody.
And would you say maybe calculus still does have a role? Maybe it could fit somewhere in the integrated curriculum. I know in a lot of other countries they require calculus to be part of their high school, but it isn't like a standalone class. It's part of the entire the math curriculum.
I think there's definitely a place for calculus for in the high school, but I'd also come back to the why is calculus sort of that standard bearer, and why does everybody want to get through calculus? That for many careers, calculus is not going to be applicable to a career. And when I'm thinking, statistics, that's a very applicable thing to other types of careers. Or there's a quantitative reasoning course that some are doing. And by the time you hit that junior senior level, you start to have some sense of what type of career path you may want. Now, you may not know exactly what job you want or what career, but you have some idea. Do I want something in the hard sciences? Do I want something in the humanities? Do I want something in the arts? You start to have some sort of idea there. So why aren't we giving our students opportunities then in that third and fourth year, especially that fourth year, to take a course that's going to align more with their interests, rather than, oh, we've got to get you through AP calculus because somebody thought long ago that calculus is the most difficult, the most rigorous, that top course in the world.
And are there any examples of detracking being implemented and having a lot of success that you've seen so far?
I would say there are a lot of places that are early on in their journeys with detracking. There are some that are further along with that. There are some schools in California that have detracked, but there are schools, as I go around the nation and work with different school districts and work with and speak at different conferences, I'm hearing more and more stories of places that are beginning to implement that detracking. And the early results from the districts, they say, more and more students are taking higher level math classes than ever took before. And the early results from many of the places are very, very positive and encouraging. But it's not just the district are also saying it's not like we just got rid of detracking. We're also looking at how are we teaching the mathematics. That just eliminating tracking is not going to be the magic cure. We have to also take a good hard look at how are we teaching mathematics? Are we making mathematics relevant to our students? Are we recognizing that because of technology, the mathematics, the way we teach mathematics now should not be the same way as we taught mathematics 20 years ago, because there's so much more technology. And are we really utilizing that? So it's not just the detracking in isolation that districts are doing. It's a detracking along with a really reimagining what should teaching mathematics look like. And it's a combination of those two that are leading to some very, very early signs of success in places.
And would you say detracking kind of is a sort of universal acceleration where we're kind of uh like getting rid of those remedial classes and giving extra help to those who need it rather than yeah, would you say that it's sort of a universal acceleration rather than a
Yeah,
toning?
I'm not sure I would call it a universal acceleration, but there's definitely, students who traditionally have been placed in those lower classes, traditionally who have struggled. There's definitely things that need to be done to better support them. And I think that yeah, we need to continue to look at how do we best support every single student, and not just those students who we have deemed to be capable of mathematics because they were able to memorize their multiplication facts faster than somebody else. We put them in a higher math track early on, but it has nothing to do with, do they understand anything? Are they able to do some problem solving, some sense making, doing some critical thinking? And mathematics needs to be more than just finding a correct answer using an algorithmic type of a thing. That's not to say that finding the correct answer is not important. It's very, very important, but it's also important that we can make sense of what's going on and we can see that it can be applied to the world. And so often when we just give you a problem and say find the answer, you don't see any value in doing that. You don't see any way to apply it to anything. And we need to make math a very applicable subject because it's an ever growing field.
I think that's pretty much all I have for now.
All
I
right.
was just curious, what would you say is the greatest problem or challenge in math education today?
Yeah, I think then one of the greatest challenges is just resistance and people not being willing to try something new. And as math teachers, we're just as guilty as anybody else because the way that we learned or the way that we memorized math worked for us. But that's why we became math teachers. And if we're truly interested in meeting the needs of every single one of our students, we've got to be willing to try to do things differently than what worked for us if we're truly interested in increasing opportunities for every single student.
Okay, thank you so much.
You're
That's
very
all I
welcome.
have.
All right,
Yeah.
wonderful. Thank you.